Hi everybody, and welcome to Learning Module 7. This week we're going to discuss the organization and documentation of information resources. Now, in the information management fields, when we talk about documentation, we're talking about it in a somewhat similar manner as a filmmaker would talk about a documentary film, in that documentary film attempts to record the essence of an event or a phenomena. So if we sat down to watch, say, the movie Woodstock together, we wouldn't actually be watching the entire Woodstock concert from beginning to end, but we would be getting a sense of what the concert was like, what music was played, what the people were like, and we'd get an overview of what the concert was about at Woodstock. Information documentation works the same way. With documenting information, we are trying to get a concise synopsis of a larger information resource and record it so that it can be used and retrieved and analyzed. Now, in contemporary library and information science parlance, the word documentation has somewhat fallen out of favor and has been replaced with the catch term metadata. So, metadata and documentation are essentially synonymous terms. Metadata rings more with an emphasis on recording information in computer and technological information systems rather than for, say, traditional card catalogs or traditional paper indexes. Now, the term metadata is used popularly also in the information technology industry, as well as in library and information science and the information management professions in general. And it's often used either vaguely or incorrectly. So we have to take the various definitions that you'll hear in metadata referred to with somewhat of a grain of salt. However, I think the term is part of our official parlance as information managers and is a permanent part of our language. So why don't we start the lecture today with learning a bit about the history of the term metadata as it relates to information documentation and how it evolved to take over the broad field of documentation in general. So the first known recorded use of the term metadata was made by Jack Myers in 1969, and really in the late 60s through the 1970s, the term metadata was used not that often, and it was primarily used in reference to machine-readable data that could be interpreted by humans or vice versa. Human-produced data that could be interpreted by machines. The term kind of went on a hiatus in the 1980s and then reappeared again in with a renewed popularity in the 1990s. And the use of the term metadata seems to, interestingly, coincide quite closely with the development of the World Wide Web and a number of the various standards for indexing information or representing information and technologies that are related to the web like XML. And it became so popular along with the World Wide Web that metadata is now very broadly used across all information management professions. And they've sort of adopted it as official parlance, even though the word grew up in the computer science area of research and applied technology. You'll often hear people define metadata in a very self-referential and kind of useless way, that metadata is data about data. And I find that to be useless because it's very much like saying a street sign is a sign on a street. It doesn't really tell you what the street sign is there for, and it doesn't really describe the characteristic of what a sign is. But if we had to use a simple catchphrase to define metadata, I would rather say that it's information about other information. Now let's talk a little bit about what the purpose of metadata is. As I mentioned, metadata is very closely and almost synonymously related to the idea of documentation. And the function of metadata is to facilitate information retrieval and analysis through documentation. A metadata record is a record that refers to a complete information resource or document, but the metadata provides a concise, abbreviated representation of that information that can be used for searching and for reviewing and evaluating the quality or the content of an information resource. Metadata can be packaged in many different ways. And again, the usage of the term metadata implies some sort of technological application. So here on this slide, I've got two examples of metadata packaging in standard formats that are actually quite different from each other. The format on the lower right is used by the U.S. Geological Survey to track water quality data. It's called the WQX format. And you can see it's a very straightforward text-based data collection format. And it truly is a data format rather than an information format. But the definitions of each of the fields in the lower right-hand corner box there, those are the metadata elements, data elements. Each of them which conveys a particular piece of information about an event or a phenomena. The phenomena being the state of water quality at the site where the water is being measured and analyzed. The top left is a general information management format called the resource description format, or framework, sorry. And RD, or RDF, as it's often called, RDF has been developed out of XML. It's actually a variant of XML, and it was designed originally with the idea of the semantic web in mind. It's been up and coming for many years, I think since the late 90s when XML first made its appearance. And it's been very slow to catch on, but it's one of the indicators of what might be to come in the field of metadata and information representation in the future. So I have included one article that introduces you to basic RDF standards in the further readings, and I think it'd be worth your time to take a look at it. But each of these is both an information standard, in a sense, or a data standard, in that it defines how to record and capture specific types of information. There's also a technology side to both of these standards. One, the water quality exchange format, was actually designed to be the output of a sensor, a piece of hardware, or the output of a computer program that analyzes water quality. Resource description framework, on the other hand, is a universal information management standard that attempts to be able to describe any type of information resource anywhere. They both use specific technologies to implement them, but they're actually extremely different in how those implementations occur. Now, going forward with the discussion of what the purpose of metadata is, or what its functions are, we can easily define these 6 major functions that we use metadata for in describing information resources so they can be easily retrieved. The first function is identification of an information resource. It's either a unique number or identifier, or a combination of unique fields that describe the information resource that distinguish it from one object that is unique from many other objects. And certainly an identification device could be a library book call number. It could be a digital object identifier. It could be any other. It could be a simple serial number, or a record ID number in a database. The purpose is to give it a generalized, unique identification of one resource that lives among many. The second function is to describe the information resource, to describe both general and specific characteristics of the resource. And those characteristics could be technical in nature. For example, if you are managing a library of digital files, you would need to keep some technical information on files, formats and types and sizes, and file sizes in bits or kilobytes or megabytes, etc. It can also be content-based information that gives a narrative summary of what a document is about. Certainly a title is usually a content-based piece of information that describes what is contained within the larger information document. Metadata also provides for access and retrieval simply because through the recording of different properties of an information resource, this allows you to sort and group resources together so that you can determine whether or not they are suitable for your need as a user. Without defining who the author is, what the title is, what the date of publication is of an information resource, we wouldn't be able to sort resources so that you would be able to retrieve the most current article on a subject, or by an author who is currently written, who is very popular in their scholarship about a subject. So the types of metadata that we keep for information resources enables us to provide good search, retrieval, and evaluation services to users of those information resources. Now, these first 3 categories of function we can group together collectively as descriptive metadata. They describe something about the information. But we also use metadata for internal purposes, not just for end users to search and retrieve, but also for tracking things like the condition of resources, technical requirements for reading the resources, whether the status of the resources in terms of whether perhaps it's a draft copy or a final copy of a report, and also whether the resource has been modified or there's some history of chain of custody or ownership of the resource over time. These last three categories we can group together and call operational or administrative metadata. You very often hear it called administrative, although I tend to feel it is more operationally related in that it's the types of metadata that you use in order to conduct your daily business operations, whether you're in private business or in government or in academia. In terms of the descriptive function, let's make one more clarification about the difference between identification versus description, although identification usually is a subset of the descriptive process. So if I'm going to identify a specific information resource, like we've identified Fido as one unique specific dog, that allows us to retrieve information resources with a great deal of precision, meaning that we can go precisely to the one or several records that we need directly without having to do a great deal of searching and evaluating through multiple resources. And when you search Google, for example, Google, their whole modus operandi is to attempt to provide you with more precision in your searching so that when you search for something, they put the most appropriate answer to your query at the top of the list. Well, almost at the top of the list. Underneath their advertisers, they put the most appropriate answer to your query at the top of the results list. The descriptive function, the pure descriptive function of metadata, allows us, by contrast, to do a great deal of successful recall. So when you don't know what specific resource you want, or if you want to see what the universe of results will be for a particular resource, then you want good recall. You want to see everything on a particular topic or an answer to a particular query. So the difference here is that by searching for dog, we get a broad general selection of resources, which are many different breeds and types of dogs versus an actual individual dog. So precision versus recall is an important descriptive function that metadata serves. And we've already mentioned this, but we've already gone over this, but here again are typical identifying elements that you will see in information resources that allow you to get to access them with some level of precision. And by contrast, the descriptive elements, while they can provide precision, they also provide more generalized access to the entire content of an information resource. So in particularly in the summary here at the bottom of the page, which is a very short abstract of the novel, helps us with understanding what the broad content of the entire resource for whom the bell tolls contains. Now, metadata can, as I mentioned, can also provide a lot of technical information that we can use to either describe the information resource or to manage the resource. Here, for example, if we were managing digital files, digital images, we would perhaps want to keep one or more of these data elements in our metadata record about this information resource, the dog breeds picture, for example, so that we can adequately match both the unique characteristics of the resource and the technical requirements for accessing the resource. Now, some of the operational functions that metadata can provide if we record, we design the metadata correctly and record it properly, is that we can denote relationships between similar data sets or similar information resources. We can also track the status of information resources within a collection. Status can mean more than just is something good or bad. It can denote whether something is available, whether it's in good condition, or whether it's freely available or requires the payment of a license fee. And then whether something has been modified, as in how much it has changed over time. Now, this can be more useful for physical items like paper documents or records that have some tangible form that are actually going to decay or weather or get some wear based on their use. But modification can also tell you whether you are looking at the final version of a document, or if you're looking at a derivative version of a resource, or if there's been some change in the format of the resource over time. So metadata will tie in a lot more specifically in a couple weeks when we talk about digital preservation. As I mentioned, we have both descriptive information and we have operational information in terms of what we collect as metadata. I think it's important to visualize the two different types of information, because very often when we as information managers are designing a new set of metadata fields, what we put together and call a metadata schema, or a complete set of fields that describe an object, very often we just think about the identification and description needs of our metadata. And that's typically what users want, is they want to be able to search for information and identify unique pieces of information, and then to be able to evaluate the information using descriptive information. But as information manager, and we also need to track various aspects of how the information is used, what condition it is in, what status it's at, whether it needs to be replaced or it's becoming outdated and needs to be upgraded. All of those aspects are sort of behind the scenes. So we can envision metadata as an iceberg in which the users tend to see what's above the waterline in terms of the iceberg, but we know that there's a huge amount that's below the waterline that we can't see right away in an information system. So when you go to design a metadata schema, make sure that you take into account all of your needs above and below the waterline. That leads us to talk specifically about how metadata is structured. Now, when we think of catalog cards in a traditional library catalog, even in those cards, we know that there are distinct field elements such as author, title, date of publication, publisher. Those things are those elements are fields, and in likewise, in metadata creation and development, we also call those individual items elements or fields. And this goes back to actually database technology evolution, in which the elements that were defined by library catalogers in the 19th century to be able to distinguish, unique characteristics of books and journals were rolled into the idea of fields and columns in database technology. And then we've pulled the reference to fields and columns in databases into now describing electronic documents, books, journal articles, and other kinds of documents in digital terms. So each discrete unit of metadata is called an element or a field. Now we define each field to describe one piece of unique information about an information resource. And often we refer to that one piece of unique information as a facet. A facet is an exclusive set of information that we don't replicate in our description anywhere else. So for example, we usually see one author field in a metadata schema that describes bibliographic information. We don't see multiple author fields. So authorship or statement of responsibility is a facet of the book information object. Title is also kind of a facet, but date, certainly date of publication, is a facet. So what we're trying to do when we define a metadata structure is to determine what are the facets, the unique individual pieces of information that don't overlap, that together will describe the entire information object. We also have to, in terms of being able to do good retrieval, sorting, and grouping, we also need to concern ourselves with the internal order of each field, which we'll call syntax and formatting, or formatting and style. Style being punctuation, capitalization, and form of entry that we make into each individual field. And when we group a set of fields together to make a complete picture of an information object that we're representing with metadata, we call these complete sets schemas or frameworks. The schema, the term is borrowed from, again, database technology and design. But a schema is simply a collection of related fields that together will be used to describe one type of information resource from a collection. And that schema is used to both record the information and to help systematically identify unique pieces of information in that collection so that users can easily retrieve them and evaluate them. Now, when we create a set of fields that we are going to use to describe a set of information, we can call that a specification, because we're going to specify what elements our metadata fields need to include. And a specification document, you're going to write one for your assignment, should include the parts that are shown graphically on the screen here. When we start a schema, we need a mission statement. We need a definition of what the schema is intended to do. We'll call that the schema definition. But that should say, well, this schema is intended to describe digital images that are in, let's say, the Museum of Southwestern Biology at the University of New Mexico. And this schema will also have to mention how we're going to implement this schema. And this schema that describes digital images at the Museum of Southwestern Biology also is going to be implemented using a SQL Server database with a custom front end. And so the schema will be implemented as a part of a database. So it's important to have both the descriptive definition and have a technical implementation statement in your schema definition. Now, each individual field needs an identifier like title, author, publisher, etc. It also needs to have a definition of what goes in that field. So when I say that my first field in my schema is going to be identified by the tag title, well, what goes into the title field? We need an actual description of the information that is appropriate to go there. Now, our field definition should specify both what kind of information goes in that field and where we're going to get the information. So using the title example, our field name is title. What goes into that field is we want to take the publisher's official title off of the first page of the book. And that's what we want to use as our source for that information. So each one of our fields, so if we had fields for title, author, or even if we had technical fields that described file format and size, we'd want to specify what specific information for that field is appropriate. And then further, with the tag, the little box that says content specification, further, we not just need to don't need to just specify what information goes in that field, but how we're going to enter that information. And that's very important that we have uniform data entry across all of our records in any sort of database or catalog, so that when a user searches on the information, they will get a uniformly sorted result. It also will help. It helps users being able to read the information. It also helps searching, and so that you know all of the specific style and formatting elements that go into a field. So for a field like title, we would want to specify that we're only going to capitalize the first letter of the first word in the title, and we're going to end the title with a period. For an author field, we might want to specify that you are going to enter the author name in the first name space last name format, or, if you'd rather, in last name comma space first name format, and that each part of an author's name needs to be, the first letter needs to be capitalized. So those are content specifications that tell a person who is doing the data entry or the record creation for a metadata record exactly how they need to format the information that goes in that field. Now, content specifications can also indicate whether a field is going to be a free text field, like title, or if you're going to enforce some sort of controlled vocabulary on the field. Like you might have a list of author names, or you might have a list of document types. You might also use a controlled vocabulary list for year to make sure that everybody who enters the year into the year field really only enters it with 4 numeric digits instead of letting them type in 4 digits and then AD afterwards, or trying to type actually today's date in the field rather than just the year. So content specification is very important to what we call normalizing the information. And normalization of data is another theoretical construct taken from the field of database theory. Also, some fields are related very closely to each other, and so they need to be grouped together. So some fields, they only maintain their inherent usefulness when they are grouped with another field. So for example, if we use the author field as our example here, we'd have one field for author name, And then say we needed to record the author's life dates, like their birth and death dates. Well, without the author field, the life dates field doesn't really have any utility or meaning to the end user unless they're grouped together. So it's important that you think about all of the different fields that you need to collect data for to create a good representation of your information resources, but also how are they grouped together. And you see the vertical bar on the left that says section or group definition. It's important when you have groups of fields that need to stay together that you define what those groups are and why they are grouped together in your specification document. So this is a summary of what we just discussed using the graphic. A metadata structure specification document or metadata schema specification, you can use them interchangeably, the terms interchangeably, needs to have a definition for the entire schema. What is the purpose of the schema? We need to identify groups of fields and why those fields are grouped together. Every field needs to have its own identifying label. Every field needs a definition of what goes into that field. So when I label a field title, what is appropriate to go in the title field? What does title mean to you? Then we need to know how to enter the data into the field, the content specification. So do we capitalize certain words or do we not? Do we leave it all lowercase? Do we allow numbers in this field or just text? Do you punctuate this field or not? Those are content specifications. And then also, as part of it should be as part of the schema definition, but you should include a technical definition of how the schema is going to be implemented. Because different schemas are designed for different purposes. Like an RDF-based schema is actually designed for use in a web application more than it is for a database application. The same thing with the plain text format that we saw for the water quality exchange format. It's really designed to be extracted and manually analyzed or analyzed by a program. It's not meant to be published as a finding aid for a set of data. Now here's an example of a very popular and commonly seen metadata schema. In fact, it's probably the first major effort to create a general information management descriptive schema. This is called the Dublin core. The core refers to, it just provides a general core of fields that are important to most types of information resources. And the Dublin refers to the fact that the conference where this schema was developed was originally in Dublin, Ohio, and that was done by sponsored by OCLC, which is located either there or nearby. And OCLC is one of the great library services and online database providers in the library profession. So Dublin Core used to be much more important as a web resource identifying standard when it was originally developed, because search engines were not anywhere near as sophisticated as they are now, and in order to index your web page that you were putting on the web, you needed to actually call these tags, these fields out as tags within your HTML code so that the indexing service on the search engine that was going to crawl over these could identify what the title is of this document, so it could be added into the web crawler's indexes. Nowadays, you actually don't need this set of fields to be embedded in your web page. It can help in certain instances, but it's not going to enable Google to crawl any better over your document. In fact, Google generally ignores these tags anymore. They don't look for specific tags the way they used to. However, Dublin Core, because it's such a generalized metadata schema, has been applied in a number of different other scenarios. So, for example, a number of different specialized information managing organizations, like the Visual Resources Association, has developed its own variant of the Dublin Core that they call VRA Core, which actually starts with the Dublin Core and adds on many additional fields that are used for managing audiovisual resources. Here we can see, however, in this chart of Dublin Core metadata that in the left column I have identified the function that we discussed earlier, the different functions that metadata performs. We have the element names. These are the field identifiers. We have the element definitions. So these are the fields defined what information goes into each field. And then the syntax tells us what our content specification is. How do you enter the data into that field? And this is a good example that you can use when you are designing your own metadata schema of how to structure your basic schema information. Now, when you're designing a metadata schema, as I mentioned previously, we try to normalize the data so that they are unique individual elements. Each field in the metadata schema is a unique element, and the elements don't overlap in coverage. So, for example, we don't record author more than once. Like, we don't have an author and an author title field. We divide those two data elements separately, and we don't mix them up, and that allows us to both search more easily, especially in a database kind of context, and also to present the information more easily to the end users. The second thing is to try to standardize terminology as much as possible across the metadata, and this has to do with the individual field definitions. So wherever possible, try to implement controlled vocabulary in each of your fields. So instead of just letting somebody type in the year field, type whatever they want, could be like today's date, or it could be a year, or it could be a year and AD or BC or something like that. Wherever possible, turn those into controlled vocabulary fields, which then, when they're implemented, would become drop-down lists or pick lists that users would select values from rather than type in their own values. And a good number of metadata elements can actually be standardized in this way, whether it's technical metadata. So, for example, if you're managing image files, technical metadata fields like file format, file type, could be easily standardized and made into controlled vocabulary fields. Fields like file size and file name certainly can't. Those have to be free text fields that you have to deal with people entering data directly into those fields. But standardizing information helps with retrieval, and it helps prevent against both retrieval errors due to misspellings or wrongly formatted data entry, and it also helps lower the confusion on the part of users who have to look at the metadata records. And then the third design consideration is to think about all of the different needs you have for designing the metadata schema. So if you are starting a new job in an office and you're asked to design a database that will manage PDF documents at this office, think about all of the bits of information that you're going to need to collect about those documents. Not only are you going to need to collect author and title, but you might need to collect what department they're from. You might need to collect how long to retain the documents before they become outdated and need to be replaced. There are a number of administrative or operational considerations, what's below the waterline with the metadata iceberg, that you need to consider. So try to, when you're designing your metadata schema, visualize all the different functions and uses and purposes of that metadata that you're going to need to implement. Now we should mention that a lot of contemporary metadata standards are designed to be interchange formats as well as descriptive formats. By interchange, we mean that they're not only meant for people to see and use directly as end users, say, on an information system, so that they can evaluate content of larger information resources, but they can also be shared between systems or used in different kinds of contexts. So one of the big moves in open access publishing and is to develop standards of interchange in the metadata frameworks for scholarly publications, where different systems can harvest metadata from many other different systems, and they can share metadata about records much more easily. If you have a chance to look up the OAI PMH standard, that's the Open Archives Initiative. The OAI protocol requires a certain type of shareable metadata framework that allows systems that run that service to be able to harvest each other's interchangeable metadata schemas. Crosswalks. Now, since we have so many different metadata standards, and one of your readings is actually to take a look at a nice chart that lists all of the different kinds of metadata standards that are available across all different kinds of information management fields and research disciplines and so forth. Since we have so many standards, we actually have a glut of metadata standards. There are actually too many to be very usable just on their own. So when we develop metadata schemas, we're always thinking about what standard can we apply to that schema, and then how would that particular standard that we implement, how is that going to talk to another system that uses a different standard? And the way we, both intellectually in terms of design and also technically in terms of programming and system implementation, we typically use these things called crosswalks, which are simply guide maps that link what one field is called in one metadata schema to what it's called in another metadata schema, and provides instructions on how you would interchange data, because the content specifications for those two different schemas are probably also going to be different. So until such time as we narrow the field of metadata standards that are wandering around for many different disciplines and purposes, until we sort of hone in on what are the most important schemas and standardize across many different disciplines, we'll have to use these crosswalks to be able to convert metadata from one system to another. And then finally, XML is pretty ubiquitous these days. We hear about it a lot, and it's implemented in many different types of systems, especially systems that provide a web type of interface. And it looks like description format like RDF is going to succeed XML. It's XML based, but something like RDF is going to be the next generation of metadata packaging technology that allows us to mark up or encode metadata in such a way that both humans and machines can understand it easily. So that's sort of a broad general view of the practical issues in creating and documenting metadata schemas, and how you should apply the design process to your particular information environment. Let's go ahead and just review what's happening this week in the Learning Module 7. Hopefully you got to read the little introduction, and we're now done with the online lecture. I've got 2 articles, and the chart that I mentioned is your assigned readings. The first reading, Understanding Metadata, is a good general overview from the National Information Standards Organization, or NISO. And some of it's a little dated, but it gives you a good breadth of understanding the whole landscape of structured metadata and schemas, and the different types of schemas that are out there and what they are used for. The second article is a good, again, a good introduction that's more related toward library resources, but the focus is broad enough to be useful in understanding the differences between types of metadata and metadata standards. And then that chart, I'd just like you to take a close look at that. And it lists in just the names of many different metadata schemas or standards that are out there. What I would like you to do when you look at that chart is to find your own area of your own professional or academic research area, and look up those standards that are listed on that chart that apply to your area of work, and just review the major standards in your area so you're familiar with them. Now, for your assignments this week, you need to finish the data production assignment from last week, and that's due on Sunday, the 7th. And then I have detailed instructions on the introduction webpage for the learning module on creating your own metadata schema for your own particular information management environment. I'd like you to write that up as a Word or OpenOffice document and upload it into the Week 7 discussion area, and then review your classmates' work and comment on at least 3 of their metadata schemas. And the writing the metadata schema document and posting it your own is due on October 6th. I should have mentioned here. The 3 comments on your classmates' work aren't due until the 9th, October 9th. And that's on the web page as well. And I did include 2 further reading articles. One is an introduction to the RDF framework. That is a short one, and it's good in terms of just being familiar with what RDF is, because you're bound to hear more about it if you're not already familiar with it. The second is a really nice article on how metadata design has been implemented for complex and sort of difficult circumstances in an archaeological museum. So it's a fun subject to read about. It talks about Etruscan artifacts in a museum, and also how the information managers at the museum developed metadata to describe those artifacts. And it's a good sort of case study in how to develop a specialized metadata schema. Have a great week, and let me know if you need help or have questions about your assignments. You can email or call me as usual, and we'll see you next time.